Go ahead, set number one up right now. You guys can do your assumption, your given, and then we'll talk about, all right, what the heck are we going to contradict and how the heck are we going to do it? Okay, I just want to back up and review all the basics here before we move on. Why would I need to do this proof indirectly? What's your signal? Vincent, what's your signal here? Something's not happening. Prove something's not happening, so I know it's indirectly. What is my assumption on this proof here? Bother doing the numbers today. There's not, people are too absent, and I want to hear it. Not here, not here. What's our assumption here? I'm still getting nervous about this part. Emma? Always remember, it's the opposite of the proof statement. Do not touch the givens. Opposite of the proof statement. So AE congruent to CD. And some of you guys missed this yesterday when I let you do the one on your own. Use that now. Mark it on your diagram. Use it as a given. Look at these two givens. Which one am I going to contradict? Because it was real easy yesterday. It was real easy because I just contradicted the not equal one. It was real easy to pick out the one. But now, ABC is scalene, AE and CD are altitudes. Which one can I easily, maybe not easy, but easier than the other one, contradict? Thoughts here. Hi, Colin. How do I contradict its scalene? And yes, I could say it's not scalene by saying, well, if it's not scalene, it could be isosceles. Do we have the ability in this honors class to prove that triangle ABC is isosceles? And do you agree that if you prove it isosceles, that contradicts that it's scalene? All right, so that's our goal right now. Let's get triangle ABC to be isosceles. That's our goal. Because if I can do that, that contradicts that it's scalene. Whew, all right. So I need two sides or two angles congruent, right? How are we going to get there? Well, I know AE is congruent to CD. I got that. Altitudes do what? Form right angles. So I have right angles here, here, and also where E is, here and here. All right. I need two sides or two angles congruent in triangle ABC. Can you guys get me there? This is why it's a little tougher today. What you need to do is a little tougher. Anybody want to take it anywhere else here? What could I do to get sides or angles congruent? Hi, Orion. Okay, since you're going down that road, I'm going to assume, correct me if I'm wrong, that you're trying to prove triangles congruent. Is that what we want to do? Prove triangles congruent? Okay, which two are you trying to prove congruent there, Orion, so we can all be on the same page? Because there's multiple triangles in here. Okay, these two overlapping ones right here, everyone. We'll try to prove congruent, because if we can, how does that help us out? Well, if we can prove them congruent, does everyone agree? Take a look at my purple triangle here. I can say that angle right there, that full angle is congruent to, take a look at my yellow triangle, the full angle in that one. And then I'll have an isosceles triangle. Everyone good? The other way you could go about it, is there another pair we could have proved congruent? To maybe do the sides? Let me just get rid of those. Could I have proved another pair congruent here? How about these pair instead? If you wanted to do sides instead? Could have proved those congruent? All right, maybe. All right, everyone good? All right, so I'll go back to the original two. A little bit tougher today. Orion already gave us a side AC congruent to itself. And also, remember from our assumption, we knew that AE and CD were congruent, so that's another side, isn't it? Here's the problem. Anybody see the problem we're going to run into? Is the right angle in between these two sides? Does everyone see that? The right angle is not in between those two sides, so it's not side angle side. Wait a second. How many methods do we have? 5. It might not be side angle side, but what type of triangle is it? Settle down. What type of triangle is it? It's a right triangle. What can I always use in a right triangle if I can? HL. Yes. Now take a look. The hypotenuse is always located where? Across from the? And what's across from my right angles here? The reflexive side Orion just gave me. And what's a leg? AEN CD. So this is going to be HL. Okay, this is going to be HL. All right, so now that we've identified HL, this is getting tougher today, huh? Woohoo! Love it. Here we go. What else do I still need? I got the hypotenuse, I got the legs. Need to tell me before I can do right triangle. I don't have enough info to say they're right triangles, but right angles, yeah. So angle CDA and angle, if I go CDA, AE, AEC is the other one, are right angles. Ooh, not because perpendicular lines form right angles or something else here. The definition of an altitude. Okay, since this will be HL, do I have to say they're congruent? Can you? Absolutely. All right. Still correct, but you don't need to. Now I can say the two triangles are right triangles. So CDA and triangle AEC are right triangles. Anybody remember why? That they do. Right triangles have right angles. Now you can go a little HL. So triangle CDA is congruent to, make sure I match this up. Yes, Meg.
Since we just proved them right triangles, can we edit the proof there? Because they're not scalene. Never mind.
Scalene is sides.
Yes.
Right triangle are angles. You good? Okay. Good talk. You were thinking. And if the triangles are congruent, what was the purpose of getting the triangles congruent? So you could get angles, yep, DAC and ECA. Got to get those congruent. No joke anymore here, huh, kids? Angle DAC congruent to ECA. CPCTC, and then you have what type of triangle? It's isosceles. Triangle ABC is isosceles, and that can't happen. How do we know it was isosceles? What did we just do? In a triangle, yep. We just proved two congruent. Which would we just prove? Angles, yep. Imply isosceles. And then now we have a contradiction, don't we? How can it be scalene and isosceles at the same time? So that assumption's false. Meaning what's true? AE is not congruent to CD. My assumption led to a contradiction. Darn it. And what lines are those that contradiction in? Remember, it's never your proven line. 1, if you wrote the givens in 1, it's in 1. If you wrote the givens in 2, it would be 2 and 8. Scalene and isosceles are the contradictions. How about that one, huh? A little tougher, huh, honors kids? A little tougher. Anything you want to ask, though? It's still the same principles. You got to figure out what you need to contradict, but getting there is going to be the tough part. All your classmates on this field trip, huh? Where are they going? The museum? It is going a lot smoother. Sorry, did I say that out loud? All right. More challenge? You got it. Is that just a freshman field trip, or is that across the board? Is it a freshman class, or is it? Thanks for the help, everybody. What's your assumption in this one? What's our assumption? AB is congruent to CA. All right, which one do you want to contradict? Which one of the givens is it going to be easier? This one's not too bad to figure out which one to contradict. Hi, Connor. Okay, we're going to contradict that by saying that AD. How can I contradict that given? By saying AD does bisect angle CAB. Ooh, how are you going to show that? That AD does bisect angle CAB. How can I show that, Vincent, that that's a true fact? There you go. If you guys can help me take a look, these two angles right here. If you can get those two angles for me congruent, we are on our way. Well, they'll be congruent if I could get the what congruent first? Those two triangles that they're in. So everyone see our plan? Get the triangles congruent to get these angles to make sure AD is a bisector. All right. Ready to go, kiddos? I love this one because at the end, people are like, oh, this wasn't that hard. Why didn't I see this? Okay, so how can I get these two angles? Well, I already have a pair of sides I gave you. I already gave you a pair of sides. So you guys are on the hook for the other two pair. Sure, Orion. That's what we're trying to do. Yep. Thank you. Okay, why don't you stop right there? He took the hard part away from you. Everyone see? I got those two angles in the same triangle. What type of triangle is this? Isosceles, what's across from these congruent angles? Congruent sides. Not the way we like to look at it, but it's true. So we have side DC congruent to side BD in a triangle. Congruent sides are across from congruent angles. Thank you, Orion, for a pair of sides. Sure, he gave you 2 pair of sides. Need one more pair of something. Hi, Katie. Oh, look at that, huh? And people don't like this proof just because things are in different places than usual. Usually you think of a reflexive side, just a nice vertical line, but not this time. This isn't a good class today, huh? Quiet. I don't have to watch somebody shoving pizza down their gullet, frozen pizza down their gullet. That's always good. Yep. That's what happens. Go ahead, be absent. We talk bad behind your back when you're absent. It's the easiest way to do it. Enough to say those 2 triangles are congruent. Okay, so triangle ADB. Congruent to, let's see, if I go ADB, I got to go ADC. Method. Side, side, side. Why did I want those 2 triangles congruent? So I could say which angles? Angle BAD. Congruent to angle CAD. CPCTC. And if those 2 angles are equal, what do you know AD is? What's AD doing? AD bisects angle BAC. Ooh, all right. Reason? Not definition of a bisector. You know that. You know how I feel about that. How Colin's sitting in a chair, not because it's a definition of a chair. That does mean nothing. How do I know it bisects? What did you just work so hard to prove? How do I know AD bisects BAC? Because I know angle BAD is congruent to angle CAD. And what do I have here? My givens in step 7. A little contradiction. That means that assumption was false. Meaning the opposite. AB is not congruent to CA. How's this look here, Emma? Good talk. Right. Easy on the attitude. All right. Did anybody just hear that too? I'm writing down. She's like, put it in the brackets now. And I'm like, all right, calm it down. Calm it down. I just got it right. Here you go, Emma. There you go. What should be in my brackets? Better get this one right. I'm going to be all over you. Where's the contradiction? Yep. There you go. Back off next time. All right. Came in a little hot there. Any questions from you guys? I have a question. Should we do one more together? Or should I take the hands off here? Because I didn't know whether we should try 3 out together and then let you go. The homework is to finish the rest of them. So whether we do 3 or not, it's part of the homework. Or is there one you want to do? Or let me put it this way. If you keep looking, is there one that we want to do together other than 3? If you keep looking through, is anything look so intimidating that we should do it together? Or do you want to just go on your own? Can we have a talk here? Breathing, anybody? Are we doing 3 together or no?
Yes.
Okay, here we go. 3 and then you're on your own. All right, what's your assumption on this one? Angle 1, congruent to angle 2, got it? I can use that as a given, and I also have parallel lines. Oh, back in the day we talked about these. What's your goal? Which given you want to contradict? By saying we need to get MA congruent to AT. Yep. It's actually a little bit tougher. It messes with your mind because you think you got to do this, but you can't do it. So you got to find a different way. MA congruent to AT. Here we go. I have parallel lines. I have a pair of angles congruent. Anybody want to get a conclusion from, hi, Roman, the parallel lines? You are correct, sir. That is a correct statement you just told me. That 2 and 3 are congruent. Anybody remember the names of those bad boys? Yep. How do I? Ooh, it's been a couple of units. How do I start this reason? Go ahead, Roman. It's your show. Oh, well, one job. One job. There you go. Still waiting for the last word there. There you go. There you go. Perpendicular. All right, still waiting. You use the parallel lines. Hi, Orion. Ooh, 1 congruent to 3. Is he right? Yeah, why? Because 1's congruent to 2, 2's congruent to 3, so that must mean, yep, 1's congruent to 3, a little thing we used to call substitution. Whoa, whoa, watch your mouth. This isn't a one-person show here. All right, 1's congruent to 3, so I bet a lot of you thought we were going to try to prove triangles here. So we could say CP, but there's no triangles here you can prove congruent. 1 and 3 are congruent. I don't know if anybody sees it yet. 1 and 3 are congruent. What type of triangle did I just highlight? Isosceles. So Orion, what's across from 1 and 3 that are congruent as well? Yes, in a triangle, congruent sides are across from congruent angles. You cannot get MA congruent to MT by CPCTC. It's not going to happen. There are no triangles here to prove congruent. So I need to do it slightly. Yep. In a triangle, look at all these theorems here. We got a unit 2, a unit 3, and a unit 4 theorem all in one. That's why this class is so great, not because of students, but because things never leave. And then a contradiction. Only 6 steps here. What do I have here? Okay. You didn't want to tell me that, Emma? You've been on my case all class, so why not continue it? I appreciate that. Good one. Good one. I guess I would need feelings to hurt, right? And I would need the ice to melt off my heart, which is very tough to do. Let's see, 1 and 5 here. 1 and 5. All right, you guys are on your own now for those, next 3? All right, that last one's a little tough, so take your time. If you're stuck, call me over. Don't ask me to look at it because everything's up on Aspen.